Today we're at Piano Solutions workshop. We try to show you some very critical aspect of trap work on the piano, and in order to understand how it works, I built this model, and of course it's represent the copy, it's a replica of Steinway. All the dimensions has been taken from Steinway assembly. The rod, the metal rod, the same distance, and the top level is actually Steinway. That's why it's identical in the motion, like a Steinway trap work. Anyway, what I've been interested in, I want to see what's happened here on the tip of the metal rod and the upper level, how it works. Actually, as you notice already, this point has got a lot of wear in the real life. It's always produce a noise and constantly lubricated. Of course, there are some other points that you have to take care about, but that's the one of them. And for us to understand what to do and how to deal with this one, we have to set the experiment. And I built this model just for only one thing. And it's already prepped. You see, we set up this level, pedal level, horizontally. The top level slightly goes down. Most pianos, you notice that they the same way. And what we expect here, on the tip of this rod, I mount the graphite from the pencil, and it's going to show us what's the motion on the level is. And now we just actually proceed. I move it several times, like that. And then we'll see what's the marks on the paper. I take the paper off the level. And as you see, it's the line. It means our point moving on a distance of approximately 1/4 inches. And it's of course enough to get a lot of wear, and it's produced the noise. But what we have to do, how we're going to deal with this, actually it's very simple, but we have to understand a little bit geometry, how it works. Here on this circle, you see I show the motion of a radius, and if the radius from horizontal position go up, you see it's the projection is moved towards the center. It means if you look what's going to happen with our rod, since it moves here like that, then the top is going to move off and on an opposite direction. And of course I show here the position of the guide that's eliminate a little bit motion here. And of course you can calculate actually dimensions, how much it goes, I mean the distance of the motion by using this equation. You use the cosine of the angle, but the problem is that you have to measure the angle of this motion, and that's complicated. Actually, it's not going to be so practical in real life. Like always, the mathematics on the piano, it's okay to understand how it works, but it's not so much application because it's very complicated systems here. Anyway, that's just for your understanding what's going on. And in this case, based on this sample, you see if I move my rod in this direction towards the center of rotation, you see the top going in this direction. What it means my rod moving in this direction towards the back, and my level in this position. Mostly when I push it, you see, it goes to horizontal position. It means it moves in this position. They just works against each other, and it's create a lot of wear. what we have to do? We have to put this top level in a horizontal position. It means I can do it. You see, I made this model specially adjustable like this. Horizontal, it means square towards our rod. And let me put a piece of paper. Because what's going to happen now? Now our level, when it goes up, goes in this direction, and our rod goes in this direction. Let's make experiment to check it. I do it like this several times. Like that. And you see the point. It means from the sliding motion we move to the rocking motion. And of course rocking motion is definitely just, you don't have to lubricate it. It's just going just like side and side, and it can last for a long time. Yeah, that's why we just, first of all, we can really recommend just how to position our levels on the Steinway pianos. Of course, you can even adjust it with your guide. I made it adjustable here, and get a real just like zero just motion. And that's of course just like that's what we have to achieve. But in order to get this knowledge, you always have to build some tools, and I hope that we just proceed with these things to investigate a lot of interesting things on the piano, especially on the regulating action. And actually we have to investigate what's happened with the dampers when we want to achieve quarter dampening or the half dampening, this effect that can be achieved by the certain just adjustment inside the action. You might never hear about this one because, right, it has to be set an experiment to get any knowledge about the piano. And if you watch our videos, we promise you to give you more very important information. And once you know about these things, believe me, it's going to be you'll be confident, and your work will be just perfect, and you always can solve any problems with the piano restoration and piano regulation and adjustments to whatever you encounter with. Thanks for watching this video, and we're waiting for you on the next one. All the best to you.